Probably will go right up to the end, so if you have to leave, that's okay. My students, I have a sign-in sheet down here. Please put your name and the course number. I will also have my lovely assistant pass out a handout that not only has some links to some interesting resources that relate to this talk and global warming in general, but on the other side, we have a very famous scientist coming here on Tuesday, May 8th, Nobel Prize winning scientist. He's also going to do book signing, and that's also on the back, but I'll have that on the slide. So I'll begin. I'll introduce myself. My name is Scott Mandia. I am professor of physical sciences here at Suffolk County Community College, this campus. I've been here for 21 years. I have degrees in meteorology. In the last 4 years, I've become very active in climate change science communication. I started a group called the Climate Science Rapid Response Team. That is a group of 145 of the top international climate scientists that field questions from the media and lawmakers. Just to give you an example of people who ask us for help. Last spring when we had the severe weather, all the tornadoes, President Obama's office contacted our team and said, is there a link between global warming and tornadoes? And our scientists gave a nice 16-page summary. And if you're curious what we said, tune in next week for, no. If you're curious what we said, the science about climate change and tornadoes, think of a recipe, you'd have 2 ingredients. Tornadoes need 2 ingredients. Hotter, more humid air, that's absolutely increasing. Thunderstorms are getting stronger, they're getting wetter. No question about it. But in order to get a tornado, you also need twist in the atmosphere, we call wind shear. There might be less wind shear in a warmer world, so it's going to be which one wins? More of one ingredient, less of the other. So the bottom line is there haven't been enough tornadoes in the last 30 years to really come up with that. But as you'll see with my talk tonight, and I tell my students, if we never have another hurricane, if we never have another tornado, the drought, heat waves, floods, and fires are enough for us to take action. Tornadoes and hurricanes are just kicking us over down. Okay? But they're sexy, they're newsworthy, so that's what people want to know. Another group that I recently organized in January was called the Climate Science Legal Defense Fund, and I co-manage that with another person. We accept donations tax-free to help scientists defend themselves in court when there is what we think of frivolous lawsuits, trying to get emails and whatnot, and also educational outreach. So climate scientists, because it's become a very political topic nowadays, some people don't like the science, so they go after the scientists, and we are giving them an education about what your rights are and some of the things you can do to protect themselves. So those are the 2 groups that I've done. My primary mission, though, is to educate students and the general public here about meteorology and climate. Hopefully, when you leave here tonight, I will have, I'm going to have about 30 people, 30 ambassadors who can go out and then start talking about this to their friends, enemies, colleagues, parents, whatnot. Hopefully there's at least one slide here tonight that resonates with you that you can tell somebody about. It'd be great if 40 slides. So I'll begin. By the way, I did not make this graphic. I have permission from the designer, but I just think it's an awesome graphic. It shows the connection between the Arctic and cities. You see we're cutting trees, sea levels are rising. I just think it's an awesome graphic. I will post this on the web probably tomorrow morning, and so this will be available. I'm also going to be doing this presentation again on the Grant campus Wednesday during Common Hour. Okay? I was there. This will be the 4th time I've done this talk in a week. Okay? So hopefully I got it down. All right, so tonight we're going to start off with... is that too dark? No, some of you are going to take notes, right? Hang on. All right, I guess I'm not going to get it as dark as I want it, so... Advanced degrees, but I can't use the switch. All right. The planet is warming. There really are very few people out there who deny that the planet is warming. That's really not debatable. If anyone says we're not warming, you can immediately dismiss anything they say after that, because that's essentially like saying the Earth isn't round, it's flat. So some of the evidence we have that the planet is warming, we see that Arctic sea ice is melting, and this is the volume of sea ice. Most of the time on the news, you'll see pictures about extent, visually how much is extending out from the poles, but that doesn't tell the whole story. What's really important is the thickness of ice. How thick is it? And the thickness is rapidly decreasing, and you can see the last several years It's been more than 2 standard deviations away from the average, which is significant. It means it's a big change from what's normal. And although there are wiggles, there's a clear downward spike. Some scientists actually call it the Arctic death spiral, and there are estimates that perhaps by the 2030s, maybe 2040s, that the entire North Pole will be open water during summer. There won't be any ice at all. Okay? So, one of the complications there is Santa Claus's workshop, is at the North Pole. So he's going to have to adapt. It's going to cost him money. So probably a few less gifts under the tree for us, right? We also see global air temperature increasing. This is primarily what you hear people talk about. They talk about air temperature increasing. That's just one metric. It's just one measure of climate change. And you can see there are wiggles. And so what happens sometimes is you can look in here and you can see there are some periods of 10 years or so where it looks like temperatures maybe drop down. But certainly when you look at the whole picture, the trend is up. Okay? And 2010 was the tied for the hottest year in the instrumental record, since we've had thermometers over large areas of the globe. 2005, 2010 were the hottest. Okay? We take a look at Antarctica, and you can see the amount of ice in Antarctica is decreasing. It's not decreasing nearly as much as the Arctic because Antarctica is ice on land and it's really high up. So if you think about it, if it's minus 40 there, and human-caused climate change warms at 20 degrees, it's minus 20. You still don't get much melting. The Arctic, on the other hand, is generally at sea level, so if it warms, it melts. And by the way, you can melt water 6 times faster than you can accumulate it, so actually summer temperatures are far more important than how much snow falls in the winter. Because every minute the temperature's above 32, ice is melting. Every minute the temperature's below 32, it isn't snowing. So it's always going to melt when it's warm. It may not always accumulate when it's cold. However, Antarctica is melting. And that's actually scary because that's a very, very cold place. And I'll show this in the next slide. Ocean heat content is essentially the barometer for climate change. And you can see that ocean heat content is absolutely rising. So why is ocean heat content the true measure of climate change? Of course, you don't hear about that in the TV or radio. You always hear about air temperature. Because look where global warming goes. Over 90% goes into the ocean. The heat capacity of water is tremendous. You know that because it takes a long time to heat up a pot of water. It can take a tremendous amount of heat before it gets really, really hot. In fact, there's a neat experiment where you can get a balloon, you put one of those Bic lighters against it, boom, it pops. A water balloon, you can put that Bic lighter there for a minute and the balloon doesn't pop. Okay? So if you look at ocean heat content, it's going through the roof. So the oceans are gaining heat. It's got to be coming from somewhere. Okay? Oceans are gaining heat. So the next time somebody tells you, oh, last year globally it wasn't that warm, or the last 5 years maybe globally it wasn't that warm, say, well, that's just air temperature. If ice is melting, that takes heat. If the oceans are gaining heat, that takes heat. So look at all of the metrics, but I think ocean heat content, ice melt, really are better indicators of climate change than the air temperature, because so many things influence air temperature. You know that just even on a given day, a cloud goes across the sun, you might get a 5 or 10 degree change. Heat content, ice melt, those are the biggies, and those are definitely increasing. And you can see the change in heat, land, and atmosphere is dwarfed by ocean. Okay? So we'll do some physics without using any math. That's always the best way to do physics, right? Probably agree with me on that. Sorry, Tom, a physics professor back there, shaking his head. Basically, if you think of the climate system as the atmosphere, the surface, the ice, and the ocean, that's the system. Okay? We get energy from the sun, that's coming from outside, and then the Earth tries to radiate that heat back to space. And we know that happens because if it warms up 25 degrees in the afternoon, if it didn't cool off 25 degrees at night, each day would be 25 degrees warmer. We also know seasons. Summers get warmer because we're accumulating more incoming energy because the days are longer. We don't have as much time to lose heat at night. Winters we cool off because we have 15 hours a night, more time for it to leave. So we want to look at the incoming arrow from the sun and the outgoing arrow from the Earth. Now, hopefully I've convinced you that the planet's gaining heat. The only way that can happen is if the incoming arrow is getting bigger over time, or the outgoing arrow is getting smaller over time. It's really that simple. You know, the details aren't, but that's the bottom line. Think of this as your checking account. if your checking account is increasing, I know you're like, what? I know. If your checking account is increasing, that either means your deposits are increasing or your withdrawals are decreasing, right? I mean, the details are the everyday transactions, but that's the bottom line. So let's take a look at the incoming arrow. When we take a look at the incoming arrow, we got to measure how hot is the sun, because it does change. And a way to do that is to count the number of sunspots on the surface. Because although the black spot that you see in the sunspot is actually a cool, around the edge, these things called faculae are actually very, very hot. So when you have a lot of sunspots, there's more energy streaming toward the Earth. So we say the total solar irradiance is increased, more incoming heat. When sunspots are low, there's less heat than average coming into the Earth. So if you actually take a look at the curve from 2000 to 2012, you can see that in 2010, there were almost no sunspots. In fact, it was 100 years before we've seen the sun this cool. And we had the hottest year in the instrumental record. 2005, well below average number of sunspots. 2001 to 2010 was the hottest decade in 150 years. And during that decade, we had a weakening sun. It was colder than normal. So the down arrow is actually a little smaller than normal. Our deposits are a little bit less. If the planet's gaining heat, and we're actually getting less from the sun, the only way that can happen is if there's less heat escaping. And so the outgoing arrow is definitely smaller. And by the way, we've measured this with satellites. We have satellites up there actually looking down, measuring the heat coming out of the Earth. And they're measuring less heat coming out of the Earth. They have to. Physics can't be denied. The oceans are gaining heat. They can only gain heat if the sun gives it more or if the oceans give off less heat. Okay? So, how do we know it's because of humans? Because we know that certain gases in the atmosphere trap heat. We call those greenhouse gases. They trap heat. Now, most of us visualize a greenhouse. We think it's a nice place. Okay? The idea of a greenhouse gas is that sunlight can go right through, but then it's difficult for the heat to come back out. It doesn't really trap heat as much as it slows down how quickly it can escape. So over time, you're going to warm up. So what we have now is the nights are getting warmer faster than the days. The nights are when we lose heat. If nights are warming faster than days, that means something is preventing the heat from escaping. Winters are warming faster than the summers. And I'm going to show this too, by the way. I'm not, right now it's text, but I'm going to actually show you this in the United States. This is true. Winters are warming faster than summers. Well, the winters is when we lose heat. Summers is when we gain heat. If it were the sun, summers and days would be getting hotter. And high latitudes near the North and South Pole are warming faster than the equator. Well, the sun isn't even out for 6 months at the North Pole. It's not the sun. It's heat trapping. And so you look at this picture, sun keeps coming in, the heat's trying to escape, comes back down. That's an oversimplification. You can think of greenhouse gases as putting extra blankets on at night. You stay warmer because the heat's having trouble escaping. The physics isn't the same, but the visual works. So it's okay to tell somebody that CO2 traps heat like a blanket at night, even though the physics is a little different. The bottom line is the same thing happens. It gets warmer. Okay? So we're putting more and more blankets on at night. So, do we have evidence of this? Well, I'll show you the United States because, we're number one. I'll show you the U.S. But this is true globally. Take a look at this. What these are the new normal temperatures for the United States. Climate is determined as 30 years of time. So, for example, if Selden's normal high for today is 61, that means the last 30 years on this date, average of all the high temperatures, it equals 61. So it's 30 years. Every 10 years, the National Weather Service issues new climate normals. So they use the last 30 years. So every decade, they go to the last 3 decades. So we can see that change. And what you see in the top pictures, these are low temperatures, these are high temperatures. And this is the change. you can see there are places in the United States that have changed about 1 degree Fahrenheit for low temperatures. But those same places maybe only warmed up during the day by about 1/2 degree. So if you look, most states here are warming faster at night than they are during the day. Then we look at seasons, winter, summer. If you notice, winter, most places are warming. In the summer, places are either neutral, some are even cooling. In fact, this is called the warming hole, because you would expect with global warming that everybody should warm. It's actually expected that this is going to happen. Does anybody want to take a guess, and this is not rhetorical, you can actually take a guess. Does anyone want to try to take a guess as to why, although it's warming at night in the Mississippi River Valley and Ohio Valley, during July we've actually had some cooling in the United States during global warming? Anyone want to take a guess? Yeah.
Because the ocean traps the heat, and it's not by the ocean, it's in the center of that country.
But then wouldn't it cool here too? Not a bad guess. He said the ocean's trapping heat, we're not near the ocean. The interiors always have a bigger change than coastlines. Anyone else?
Clouds
What about clouds?
reflect the sun's light.
All right. One thing that we expect and we've observed, physics tells us, models show us, is that if you warm the planet, since 70% of the planet is water, if you warm the planet, you get more evaporation. There's physically more moisture in the air. So the places where there's low pressure and storms that can squeeze it out, you're going to get clouds and rain. So what happens is, we get clouds and rain in the afternoon here, and that's blocking some of the sun. And then when it cools off at night, you don't get those clouds and rain because you don't get the heating of the day. So it's actually expected to have some cooling here and in the Northeast. These are regions where scientists predicted 20 years ago we would see increases in precipitation, and it's actually happening. Now, I don't have to convince you, because what do you think the last 2 years in New York have been like as far as precipitation? It's been raining like crazy. We've had the 2 wettest years globally the last 2 years. Floods in Pakistan, floods in Australia, floods in Taiwan. In fact, the floods in Taiwan practically knocked out the semiconductor, but people couldn't get hard drives and chips because the factories were flooded and they couldn't produce it. So it actually spiked technology prices. We had someone from Computer World magazine contact the rapid response team and said, is climate change part of this flooding in Taiwan? We said, absolutely. It's a factor. Okay? So people who are into computers probably don't think climate change has anything to do with them, but it does. Okay? Floods in Tennessee. There was a flood in Tennessee 2 years ago that hadn't happened in 1,000 years. Pakistan, they've never had a flood like that. Australia, it's just been crazy. New York, last year was the wettest, second wettest year we've ever had. And of course we had Irene and Lee, which just devastated people with floods. Okay? So the idea is moisture is evaporating from the surface. That causes drought in that location, like Texas. If it doesn't fall back down in the same spot, that place is getting drier and drier. The jet stream blows it over here to New York. Now we've got a storm that could squeeze it out. It's flooding in New York. So we're taking water from Texas that needs it and dumping it on New York that doesn't. And this is why climate change can both cause drought and flooding. Seems like it's a conflict, but it isn't. Because there's more moisture in the air, but in order to get a cloud, you got to have low pressure and sort of squeezing of that sponge. Texas doesn't have low pressure, they have high pressure most of the time. So the water goes somewhere else. So wet places get wetter, dry places get drier. And we're seeing that in the picture. All right, well, who's this guy Mandia up front? You know, I haven't seen too many journal articles from this guy. I don't see him on TV as the expert. Why should I believe him? Just because he's wearing a suit, right? No. You believe me because I'm the messenger. I am telling you what the experts are saying. Which experts are saying it? Essentially every single one. 97 to 98% of scientists who do this for a living agree that it's warming, humans are causing it. It's settled. It's as well known as smoking increases your chances to get lung cancer. In fact, the National Academy of Sciences, which is the highest scientific body in the country, Abraham Lincoln created it to advise Congress and the White House. They actually said human-caused global warming is settled science. Just like apples will always fall down from the tree because of gravity. Where there is still curiosity and research needed is how much warmer is it going to get and what are the impacts? I'm going to talk about some of those. Scientists aren't debating about whether it's warming and whether or not humans are causing it. That's done. Actually, it's been done for almost 20 years. However, you read the newspaper, you watch, depending on what news station you watch, it sounds like there's this huge debate. People who tell you it's not warming, or people who tell you we're not convinced it's humans, either don't understand, or honestly they're lying to you for political or financial reasons. If those people were to say, all right, I accept it's warming, I accept it's humans, but I don't think it's going to warm too much. All right, we can have that discussion. But they're not even there yet. Okay? Every single International Academy of Science agrees with this statement. There's not a single body of science in the world that disagrees with this statement. There may be individuals, but not the bodies. And remember, these bodies represent tens of thousands of scientists' reputations. They actually don't like to say they know something for sure. Scientists never like to say absolutely true. They always like to leave wiggle room, because if you leave wiggle room, then you can be wrong and it's okay. Okay? Scientists don't like to say something is settled. But they say gravity is settled, the earth is round, smoking's linked to lung cancer, humans are warming the planet. Okay? So why is it warming? Well, unfortunately, because of some of the things we enjoy in life, those things are emitting carbon dioxide to the atmosphere. Carbon dioxide traps heat. It's not new science. Carbon dioxide trapping heat's been known for over 200 years, the physics. In fact, a mathematician, Joseph Fourier, came up with it. Then we had some other scientists experimentally prove it. And guess which organization actually showed exactly how carbon dioxide traps heat in the atmosphere? Not a lab, in the atmosphere. The United States Air Force. Because they were developing heat-seeking missiles. And carbon dioxide was getting in the way. So they had to figure out how carbon dioxide trapped heat so they could shoot the bad guys out of the air with their heat-seeking missiles. Oh, I know, the military, those green tree-hugging leftists, right? Exactly. So anyway, the science is solid. Okay? I believe this is the scariest graphic you will ever see with this whole climate change discussion. This, to me, is the scariest graphic. Okay? The reason why is, you see these bumps here? This is 800,000 years of time. Each of these bumps is a change of about 100 parts per million of CO2. Now, what does parts per million mean? That means if we had 1 million molecules of gas in this room, one CO2 would be 1 part per million. So it's actually a very small amount. And you might actually hear some people say, come on, how can carbon dioxide be causing global warming? It's only 0.034%. There's hardly any in the atmosphere. So then you just come back to the person and say, here, take this little bit of cyanide. It can't possibly hurt you. It's just a tiny amount. Well, we all know sometimes bad things come in small packages. 98% of the gas in the atmosphere lets heat escape as if it's not even there. They don't count. So it's these trace gases that do everything. So they're the only things that matter. So even little changes then have huge impact. Okay? So this little bump here, 100 parts per million. When the atmosphere has increased its CO2 by 100 parts per million in the last 800,000 years, most of the ice on the planet has completely melted over thousands of years. Sea levels were hundreds of feet higher. That means we would be in scuba equipment right now to attend this lecture. We would. Actually, we wouldn't be here if that actually had happened. Okay? We might have gills or something like that, right? When CO2 levels have fallen about 100 parts per million, we'd be under 2,000 feet of ice if it were happening now. Now, it does take a long time for all that ice to either accumulate or melt. Okay? But the bottom line is, the atmosphere is very, very sensitive to small changes in CO2. 100 parts per million over a 10,000 year period have caused ice ages to come and go. We are here now. We are 394 parts per million. We are off the chart. We're higher than any time in the last 800,000 years. In fact, some scientists think we're higher than the last 15 million years. This is where we're going to be by the end of the century if we do the right thing. This is where we're going right now because we're actually increasing our CO2. Every year we're setting records. See what I mean, how scary this is? These little bumps gave us ice ages or no ice ages. And no ice age means every major coastal city's flooded. 1 billion people are underwater. Now again, it's not overnight, but it's putting you on that path. And we're going to be up here. So to me, this one keeps me up at night. To put this in perspective, 2010, we added 3 parts per million of CO2 to the atmosphere. 3 pieces per million. Doesn't sound like much, but the atmosphere is big. See this oil drum? Imagine that filled with oil. Try to pick it up. Very heavy, right? During the height of the Gulf oil spill in 2010, a conservative estimate is that 40,000 of these barrels were gushing into the Gulf every day. 40,000 oil drums worth of oil were pouring into the Gulf every single day. Think of the weight of that oil. Okay? Well, in 2010, we put about 31 billion metric tons of gas. A bucket of gas doesn't weigh much, so you realize 32 billion metric tons, how much gas we put in? That's the amount of 15,000 Gulf oil spills every single day. Every single day in 2010, flying our planes, making our made-in-China product, driving our car, using plastic bags, because that's fossil fuels too, just normal business, we were spilling 15,000 worth of Gulf oil spills into the air every single day. So now 3 parts per million, that's significant. Doesn't sound like it, but it is. So what's going to happen? Well, we know carbon dioxide traps heat. We keep adding carbon dioxide. It's like putting more and more blankets on at night. Now, I have some people say, come on, Scott. It warms up 20 degrees during the day, cools off 20 degrees at night. Why are you guys getting all excited about 3 or 4 or 5 degrees Fahrenheit warming? Well, the reply there is, would you get excited if your body temperature were 5 degrees Fahrenheit warmer right now?
Yep.
What if I told you it's going to stay that way for the next 200 years? You'd be very nervous, wouldn't you? Well, the climate is like the human body. It is very, very sensitive to very minor changes. Everything we do, farming, coastal cities, everything is based on the climate we have right now. And minor changes have massive implications. Just like small change in temperature can kill you. Planet's the same way. Day to day, sure it changes. Globally, on average, a few degrees is huge. In fact, most experts say that if we warm 2 degrees C, and we've already done 1, so if we warm about 3.6, 3.7 degrees Fahrenheit, we've already done 1.8, so we're halfway there. That's the tipping point. We go beyond 2C, and then we're performing the grand experiment. We're not sure what's going to happen, but it's probably not good. And by the way, most experts think we're going to hit 4 to 6C by the end of the century. We're going to blast past what is considered the safe level. We're just going to blast past it at our current rate. Now, we can exit that highway. We can. That's where you come in. You've got to be ambassadors. Tell people, get off the CO2 highway. I'm not going to suggest tonight that we no longer use carbon. We have to start weaning off. That's the key. It's always going to be with us. We have to wean off. So the analogy is, scientists are telling you, you're driving a car. Scientists are telling you, we know there's a cliff up ahead. We don't know exactly how far away it is because it's a little foggy. We're not really sure. Does it make sense to step on the gas? What should you do? At least take your foot off the gas. Then start thinking about putting the brakes on. But stepping on the gas? It's crazy. And that's what we're doing. We're stepping on the gas, meaning we're putting more and more CO2 in the air. These are my 2 boys. Humans are the most important species. Of course, we care about polar bears. But honestly, Nothing will motivate somebody more than what's going to happen to humans, what's going to happen to me. Right? Well, for New York and Long Island, sea level rise is really the biggie for us. One of our scientists, I'm actually publishing a book. It's in preparation right now. It's called Rising Sea Levels, so I gave it away. You pretty much know what's in there, right? And one of our scientists quoted the book as saying, rising sea level is an equal opportunity disaster. It doesn't care if you're rich, doesn't care if you're poor, doesn't care if you're a Democrat, doesn't care if you're a Republican. It's coming to get you if you live at the coast. You have a choice. You can move, or you can stay there and drown. For us, we can move. Poor people, they can't. Okay? So anyway, I recommend that you go to this website, sealevel.climatecentral.org, or just do a search for surging seas. Surging seas. You can actually put a zip code, or ISILCOM in New York, and it will tell you what sea level rise is going to be, how it's going to inundate the area with storms, depending on how many feet we have. And right now, the best guess is that globally, by the end of the century, sea levels will be about 3 feet higher. But for New York, it could be twice as high because of the geography and some of the geology that's happening here. We're actually going to see higher sea level rise here than places elsewhere. Now, some places on the West Coast, actually, sea levels are going down a little bit because of weather systems and the way the plates are moving and whatnot. So we could see 5 or 6 feet by the end of the century. So I thought it might be interesting to talk about LaGuardia Airport. Raise your hand if you've ever flown out of LaGuardia. All right, you see the water right there? LaGuardia employs 8,000 people. It contributes almost $12 billion to the economy in this region, New York, New Jersey. 93,000 jobs, because around the airport you see tons of hotels and taxi and all those kinds of things, right? And 4.2 billion in wages. Okay? And in 2010, LaGuardia served 24 million people. With 4 feet of sea level rise, which is a guarantee, pretty much at this point, LaGuardia is underwater every single time we have a storm. Every single time we have a storm, LaGuardia is underwater. Every single storm. Now, of course, LaGuardia is not just going to sit there and take it. What are they going to have to do?
Float.
You can't really raise LaGuardia. You have 2 choices. What are they? Move it or build seawalls. Do you think those are free? Who do you think is going to pay for that? You are. Whether you fly out of LaGuardia or not. People in Iowa say, hey, I don't care about rising sea levels. Really? Federal flood insurance pays for that. Guess where that money comes from? Taxes. We all pay taxes, right? People in New York say, I don't care if there's a drought in Iowa. Really? Do you eat? There goes the food, and what food you have is more expensive. When we had the fires and heat wave in Russia in 2010, the price of wheat went up 30% because Russia has about 19% of the world market. They stopped shipping it. Now, if you've ever known anyone that needs a gluten-free diet, wheat is in almost everything. And food prices went through the roof. So people shopping thought, wow, why are food prices high? This is crazy. It was because Russia stopped wheat export because they got hammered by a heat wave and a fire. They had to keep it for themselves. Okay? So again, it all comes down to money. When any place in the world has a hit because of climate change, you're paying for it one way or the other. It's subtle, but you are paying for it. I wish there were signs like gas prices. By the way, that heat wave we're currently having in Moscow, that's why your bread's 40 cents higher. Because then it would hit home. Just like gas prices. I wish we had signs for climate change. Okay? So the other thing for New York is hurricanes. And we dodged a bullet with Irene. The latest evidence is that hurricanes are going to get more intense. And that should make sense because I think most people in the public understand that hurricanes get their power from warm ocean water. And if we warm the planet, we know it's getting warmer. And you saw that pie graph. I mean, heat content of the ocean is huge. So they're going to get more intense, and they're going to have more flooding rains. In fact, scientists are even more confident of the flooding rain component. And you saw with technically it was Tropical Storm Irene when it hit us, Vermont had the worst flooding they've had in 85 years. How many Vermonters before Irene were worried about hurricanes? They weren't thinking about it. Now they're thinking about it. Tropical Storm Lee devastated interior New York and Pennsylvania. They weren't even hurricanes. The flooding has been crazy, billions of dollars. Okay? Now, interestingly enough, that same research suggests that we might have fewer number of hurricanes. Okay? And the reason why is El Niños hurt hurricanes in the Atlantic. They help typhoons in the Pacific. So Pacific's really in trouble because it's hotter water and more hurricanes and stronger. However, I would rather have 2 Category 1 hurricanes hit Long Island than 1 Category 3. So I actually would like the studies to show more hurricanes but weaker ones. That would actually be better. Okay? And as I said earlier, it just takes 1. And believe it or not, the insurance experts say it is possible this century there could be a hurricane hitting New York area that could cost $1 trillion. $1 trillion. That's 10 Katrinas in dollars. And that was the most devastating disaster ever as far as cost. Here's what happens when you have any kind of flooding rains. So sea levels are rising, more rain, subways flood. The mass transit in New York, 8.5 million passengers, 600 miles of track, 500 stations, $11 billion. What do you think happens to the economy of Manhattan if they have to shut down subways several times every year because of flooding? How much money do you think changes hands in New York City every day that comes from people who are riding those trains in and out? Okay? So these are the types of things people have to understand. And what's even scarier about this is that the oils and debris that float in that water, if the third rail gets electrified, it actually catches on fire and fills the subways with smoke. So even people who maybe got stuck trying to get out are going to be in smoke. Okay? So this is why they evacuated during Irene. And we came literally within 2 inches of this happening. The experts say 2 inches. So if Irene had been just maybe 5 miles per hour more, we would have seen this. Okay? And by the way, for those of you who haven't checked your homeowner's insurance, I discovered this last year with Irene. Your standard deductible, which for a lot of people is maybe $1,000, if it's a hurricane, it's 5% of the value of your home, which for most of us is $10,000 to $20,000 or more. If you're one of those homes out in there in Dune Road, it's a lot more than that, right? So that means you got to come up with $10,000 to $15,000 or $20,000 before State Farm gives you the first penny if there's damage. Who has that kind of money? Especially in a disaster. It's a big deal. Summer 2010 was pretty hot. In fact, twice we tried to take our kids to Six Flags Great Adventure. Both times the temperature was over 100. We couldn't take them for my son's birthday. You can't have kids stand in line when it's 103 degrees. So I thought we'll take them to Splish Splash. They were actually kids passing out in line and adults in Splish Splash because of the heat. So if we keep emitting like there's no tomorrow, look where Long Island's going to be by the end of the century. And raise your hand if you've been in Georgia or South Carolina in the deep part of summer. It's too hot to be outside, so what do? You go in and you turn on the air conditioner. Thank God for air conditioning. But guess what the air conditioner's using? Electricity. Where's that coming from?
Coal power.
Coal, something that's emitting CO2. So it's the worst possible scenario. New York City had an average of 2 days over 100 in the 1960 to 1990 time frame. By the end of the century, if we keep doing what we're doing, there'll be 25 days on average we're over 100 degrees. That's 25 days you pretty much aren't going to be doing anymore, but sitting in your air conditioning or swimming pool. And that's more electricity, brownouts, things like that. Buffalo, they are not going to know what to do with themselves. 14 days of temperature over 100 in Buffalo. They never see that. Okay? It's not just temperature. When it gets hot, there's heat stroke, heart attacks. When you get hot air like that, you start creating ozone and other types of pollutants that exacerbate asthma. And it's the children and the seniors who really take the hit. Okay? And you're going to see more and more of that. So that's going to be a cost too, a healthcare cost. Raise your hand if you have allergies. Raise your hand. Those of you not raising your hand, you will eventually. Because everybody has a threshold. When the pollen count gets a certain level, your body floods itself with histamines. You get all the itchy eyes, the flus, or whatever. Studies have shown that when you raise CO2 ragweed, pollen goes up significantly. So pollen loves global warming. I'm a tree pollen guy. I'm not ragweed. Right now it's tree pollen. That's that stuff that